Good evening, Mehika. Good evening.
Good evening.
How are you?
I'm good. How are you?
Also good. Okay. So we were studying that is the last class balancing equation. Did you receive the PDF?
No, but I found it just like last night because I thought you said that you would send it via email, but I found it on the website on the
Email I send you. It might gone.
I
That
didn't
is
I didn't receive an email, but I got it on the website. There was a assignment on the website.
okay. Assignment you got.
Yeah, but I didn't have a chance to do it because I only found it last night.
Okay. Okay. No problem. It's showing that it's gone to you. Mm, it's showing that is on the first Feb. I sended you the PDF. If you can check now, you will get on the
Mhm.
first Feb. It is already I said send you. I'm showing you
I have the lecture, the YouTube video, but I didn't have any
PDF.
PDF.
See the same idea I have sent you. These are the PDF. Around it is the 10 pages are there. 10 page. To check that
Mm,
what we wrote now here, the same I have sent you because you was not able to copy out the things. So
yeah.
I sent it that PDF. What I wrote on the screen that I send you. Got it?
Mhm.
Once
Yeah,
more,
yeah. I got it.
once more you check that one, please.
All right.
Okay. So today we are going to study some other concept. We are going to study the empirical formula. Balancing equation is okay, na? You got to understand that one.
Yeah.
Okay, good. Empirical formula. We are going to understand empirical formula. Empirical formula. Have you ever heard about the empirical formula?
No.
No. Okay. What molecular formula? Have you heard about molecular formula?
No.
Okay. So if you talk about the molecular formula, okay. So it is, they are saying it is exact number of molecule. It is exact no, number of molecule. Is it exact number of molecule? Yeah, exact number of, better you write down the atoms. Exact number of atoms, okay, atoms in one molecule of, in one molecule of compound, in one molecule of compound. So first of all, you try to understand that is the molecular formula. It is exact number of atom in one molecule of compound. Suppose if I am taking one molecule ethane, here we are having the ethane. Ethane formula is that is C2H6. So this is the one molecule. How many carbon is there? Number of carbon, if I am asking, number of carbon is going to 2, and if I am asking number of hydrogen, so it is going to be 6. So it is molecular formula. Okay, if I'm talking benzene, so benzene, if you talk about benzene, so it for molecular formula is C6H6. So if you see, so number of carbon atom, how many are required? Minimum carbon atom 6, and number of hydrogen atom, if you are requiring, that is again going to be 6. So this is what the molecular formula. Okay, if I am asking some other any of the compound, you can go. Okay, suppose you go
Okay.
for can you tell me the any compound formula?
H2O.
H2O is there. So H2O is the very simple one. So number of hydrogen, if you are talking about number of hydrogen, is going to be 2, and number of oxygen, if you are going to be 1. Okay, so it is
Yeah.
very simple one. If you are going ethanol, it is going for ethanol. Ethanol formula is C2H5OH. So if you see number hydrogen, how many will be required? 516. Carbon you are talking about 2. Oxygen you are talking about 1. So these are the concepts. Now you go for the empirical formula. Let us try to understand. It is what? simplest ratio of, they are saying SIMPLEST. It is simplest ratio of atoms, simplest ratio of atoms present in one molecule of compound, present in one molecule of compound. Okay, they are saying present in one molecule of compound. That you need to keep in mind, that it is simplest ratio of atoms present in one molecule of compound. Let's try to have. Okay, simplest ratio means, do you know what do you mean by simplest ratio? Can you please tell me? Simplest ratio.
No.
Okay, no problem. See, simplest ratio, if I am asking simplest ratio, it is mathematics. So least whole number ratio, least, no, whole number ratio, okay, whole number ratio means it should not be in fraction like 1:2 or 1:1, 1:3, 2:1, anything. These are the least whole number ratio. Less than 1 is not possible, less than 1 is not possible. So it is the least whole number ratio. Now see, here I am writing the compound. Let us see the compound. Then I am writing the molecular formula. Here is molecular formula. And the last one we are writing, that is empirical formula. So empirical formula is what? That is exact number of atoms. No, here what? It is exact number of atoms in one molecule of compound. But empirical formula, it is simplest ratio. They are talking about this is the simplest ratio. So let's try to have how to let's try to look on it. Yes. So here if you see compound, I'm taking the benzene, right? If I'm taking the first one, if you take the benzene, what is the molecular formula of benzene? Can you please tell me?
C6H6.
Thank you. C6H6. Now this C6H6 both are divisible by 6. Yes or no?
Yeah.
So C6H6 means that is simplest ratio. It will be that is C1H1. Yes or no? C1H1, because both are divisible by 6. So least number ratio will be that is C1H1, or you can also write that is CH. Yes or no?
Okay, yeah.
Okay, so empirical formula you got to know. It is not possible that element can be less than 1. So this is the what. Now next one, if you go next one, what is there? That is ethane. If you are talking about ethane, so ethane is what is there? C2H6. So C2H6, if you are going, okay, if you are going C2H6, so how many, what can be, this is 2 is also divisible by 2 and 6 is also divisible by 2. So it will be that
C1H3.
C1H3. So better we can write 1, not need to write that is CS3. Yes or no?
Yeah.
Okay. Suppose if you are going for alcohol, one more you go, ethyl alcohol. Ethyl alcohol. ELCOHOL, ethyl alcohol. So if you are talking about ethyl alcohol, so the formula is that is what? C2H6O. See what I did here? Ethyl alcohol. 2 is there, no problem. Hydrogen 5 here, 1 here. That is 6 hydrogen and 1 oxygen. So C2H6O. Can we write this?
Yeah.
Okay, but the problem is what? This is the if you are putting the ratio now, the same ratio will come, because 2 is divisible by 2, 6 is divisible by 2, but 1 is not divisible by 2 now. So that is because they are saying whole number ratio. It cannot be 1/2, 1/3, 1.5 like that. That's not acceptable. It will be 1, 2, 3 acceptable. So the molecular empirical formula is also going to be same, C2H6O. This is the empirical formula is going to be also the same. Yes or no?
Yes.
Okay. So did you understand the empirical formula?
Yeah.
Okay, I'm moving on the another page, right? I'm moving on another page, and I'll share the whatever I'm writing. I'll share on your share you uh, on your email ID. That I'll do. Because if you will write, it will take time. Yes, yeah, no.
Yeah.
So if you want to write, I'll give the time. There is no problem for me. I have no problem at all.
No, it's better if you send it.
So it's better if you can uh, take the, you can do the Xerox also, need not to write again and again. You can take the Xerox also, but if you will be
Yeah.
able to read out my handwritings. Hmm. So here we are having the compound. I'm giving you some more. Here I am writing molecular formula. This is what molecular formula. And last one I am going for the empirical formula. This is what empirical formula. So if you're talking about, I am talking about glucose. Have you ever heard about the glucose, name of glucose?
Yeah.
What is the formula of glucose then?
C6H12O6? No, is it?
Yeah, great. Oh my God, you know everything. So C6H12O6. So that is if you are putting the simple ratio. So this is what could be the simple ratio of the atom carbon, hydrogen, oxygen?
So CH2O.
CH2O. So it is going to be empirical formula.
Mhm.
If you are having the diborane, this is Diborane. Diborane is what? B2H6. Diborane means B2H6. So what will be that compound name in the empirical formula?
BH3.
This is going to be BH3. If I am having, suppose, acetic acid, let's see, that is last one. I'm taking that is acetic acid. If I am having this one, acetic acid. So acetic acid is what? CH3 COOH, right? Or you can write, that is how can we write? That is C2, because here two carbon are there. Hydrogen, how many are there? 4. Oxygen 2. So what would be the empirical formula?
CH2O.
Yes. So this is all about the empirical formula, right? Now the problem is what they are not going to give you the this type formula, molecular formula, and they are not going to ask you what is empirical formula. They will give the percentage mass, and then they will say that is calculate the empirical formula. That is what the our lecture today. So till now, I was trying to explain you the meaning of empirical formula. Now we are going to do that is calculation of empirical formula. Calculation of empirical formula. They are saying calculation of empirical formula. So there are some steps are there that we have to follow empirical formula. They are saying step number 1. If you talk about step number 1, so what can be the step number 1? If you talk about step number 1, they are saying convert. They are saying convert percentage mass into, convert percentage mass into which one, student? Convert percentage mass into what? We have to convert, that is gram mass. That is step number 1. Now step number 2. Step number 2. So they are saying convert. What we are going to convert? Convert gram mass. We are having gram mass. Convert gram mass into moles. Okay. Step number 3. Convert moles into simple ratio. Okay. Step number 4. If the element are, if the elements are not in, if the elements are not in whole number ratio, elements are not in whole number ratio. Okay. If the elements are not in whole number ratio, then if the elements are not in whole number ratio, then what we can do? Then convert into whole number ratio. Convert into whole number ratio. How can you convert whole number ratio? Whole number ratio. They are saying, suppose 1.5 is there. So whole number, how to calculate? 1.5 multiplied by 2, it is going to be 3. Yes or no? If suppose that is if suppose 2.5 is there, 2.5. So what we have to do? Whole number. So 2.5 is fractional. So 2.5 multiplied by 2, it is going to be what? That is 5. Yes or no?
Yes.
Good. So let's try. These are the 5 steps are there that we need to do. That is how these are the basic steps to do the calculation based on this topic. Okay, let me check out any of the problem. Let's see the problem. I got the problem. Yeah, I'm erasing this one, and then we are question number 1. Okay, so question number 1, they are saying an oxide of iron, an oxide of iron, an oxide of iron contained 69.94% of Fe and 30.06% of oxygen. Determine its empirical formula. They are saying determine its empirical formula. Its empirical formula. EF, empirical formula. What is there? You see, given is there, something is given. A molar mass they have given. Molar mass of Fe. Molar mass of Fe they have given how much? 56. 56. Actually, it is 55 point in your book. In our book, in our one, they put little simplistic 56 they have done. But in your syllabus curriculum, they have taken exact value 55.85. And they are saying oxygen. Oxygen. Are you listening, Mika?
Yes.
Oxygen is 16. Okay, good. So option number A, this is the FeO. Option E number B, Fe2O3. C, Fe3O4. Okay. Option number D, none. None of these. Only I am speaking. You are not speaking at all. Yes or no?
No,
you are not getting chance to speak at all. Yes, no?
Yeah.
Okay, good. So elements, I am writing this side. Elements are there. They are saying oxide of iron. Oxide means oxygen. Iron means Fe. Yes or no?
Yes.
So elements will be having what? This can be, that is iron. That is iron. Another is can be what? Oxygen. Iron or oxygen. Now you go for the step number 1. This is their element is there now. Step number 1, that is they said that is percentage mass. Let's write to percentage mass. Percentage mass is given, so it is not the steps. Directly I am converting. Percentage mass is given, so here I am writing percentage mass. So if you are talking about the element, Fe is there and oxygen is there. So Fe percentage is there 69.94 and here is oxygen 30.06. Now see, it is their percentage mass. After percentage mass, the second point is gram mass. Okay, gram mass. So percentage, if you add up now, this is the 100. Total is 100. See, 640, 910, 910, 63. Now that is 100. Yes, now 100 gram.
Yeah.
So if you are calculating 69% is what gram? 69.9% is what gram of what? That is 100. Out of 100 you have to calculate. So that is what we have to do. It means 69.99 into 100, out of how much? 100 cancel out, that is same come. So if the out of 100 they have given, so gram mass and percentage mass is same. This simple mathematics. If what again I'm saying, if total mass is 100, so if you are converting with the percent, means you are multiplying by 100. So 100 will be going to be cancelled out, the same mass you are going to get. Yes, yeah, no.
Yes.
69.94 here, and here is 30.06. This is going to gram, and this is going to gram. Now they are saying this was supposed to be step number 1. Here you can see what I wrote is step number 1. Convert percentage mass into gram. Got it?
Yes.
Okay. Now we are going to do the step number 2. Step number 2, they are saying that is calculate moles. Okay. So in the step number 2, we have to calculate moles. So here is 69.94 divided by how much will come? 55.85. And here is how much is there? This is 30.06 divided by molar mass of oxygen. They have given 16. So 16. You divide that, you are going to get some value. And I think this value is coming, if you are, 16 is there, it is coming something 1.88, and this is coming 1.25. This is now they are saying that is, this is not the whole number. Okay, this is not the whole number. So firstly we are calculating step number 3, simple ratio. Okay, simple ratio. Simple ratio. How to calculate simple ratio? Have you heard about the simple ratio?
Yeah, has to be whole numbers.
No, only simple ratio, not the whole number. Simple ratio. Simple ratio. Simple whole ratio, not simple ratio. Simple ratio means the ratio obtained by dividing all the numbers with largest or smallest, with smallest number. It is there in the mathematics. Okay, in IB chemistry it is there. So how can you get simple ratio? So 1 point, this is the smallest one. So 1.25 divided by 1.25, it is going to be 1. Here you see 1.88 and 1.25. Yes, 1.88 upon 1.25, because it's smallest, so this is going to be a 1.5. Now step number 4. You see step number 4. What is going to be step number 4? Simple whole number ratio. You can find here. See, if the elements are not in whole number ratio, convert into whole number ratio. They are not whole number. 1 is whole number, but 1.5 is not whole number. So with what number we can multiply both of them, so we can get the whole number. So if I am multiplying 1 into 2, it is going to be 2, and 1.5 into 2. So it is going to be 3. Yes, yeah, no?
Yes.
Now, then you can write the here empirical formula. Empirical formula, this comes the least number of ratio. So Fe is how much is coming? Fe will come 2, and oxygen is coming, going to be 3. Check. Yes, yeah, no? Fe is ratio is coming 2, na? So Fe2, oxygen is coming 3, FO3. So this is our answer is all about. So option, which option can be correct? Can you check?
B.
Option B. Yeah, thank you. This is the option B. You can check once if you understand this.
I didn't understand step 3. I didn't understand the simple ratio.
Step number 3. Step number 3 we have step number 3 simple ratio. This, can you write the any compound like Fe is 1.25 and oxygen is 1.88? Have you heard this type of ratio? No. So what we can do, firstly we have to convert this into simple ratio. Simple ratio, I explain you. Simple ratio means what? That is, suppose 1. If you suppose 1.25 is there, 1.25, 2.50, 5.00. So these are the ratio are there. So they are saying that is you need to convert into whole number. So 1.25 divided by what? 1.25. If you convert, this is going to be 1. Again, if you are dividing 1.2, this is the simple ratio will come. These are the fractional ratio. What you are going to, this is the fractional ratio. It's not going to accept set fractional ratio. Okay, too much fraction are there. So fractional ratio are not going to accept. So here at least 1 is the ratio. Now 1 will come. Then 2.50 here is 2.50 divided by 1.25. So it is going to be coming something 2. Yes or no?
Yes.
And here is the 5.00 upon 1.25. So it is not coming, it is something coming that is 2.5. But what I'm saying that 2 you got the whole number ratio. These are the simple ratio. Now they are saying these two are simple ratio, but this says not, this is the point, decimal is there, decimal. So they are saying how to calculate whole number ratio. Whole number ratio means no decimal. If anyone is asking whole number ratio means that is no decimal, that is no decimal point, no decimal point. Yes or no?
Yeah.
So how to convert? Firstly, you see here, step number 3, simple ratio. You please read the mathematics little bit, because here 1.25 is there, 1.8 is there. That is not going to be simple. They are the fraction. So what we did, we try to do the simple ratio. Simple ratio, what we did for simple ratio, divided by least number, So 1.25. So out of 1.25, 1.88, which is least? 1.25. So 1.25, 1.25 equal to 1. So 1 is the simple whole number ratio we got. But another is what? This is the decimal. So again we multiplied. So we got what? Simple whole number ratio. There is no point in this one. Simple whole number ratio. Getting my point?
Yeah.
So now simple, this 2 and 3. So Fe is going to be how much? 2. Oxygen is 3. Yes.
Yes.
So this is all about our answer. So I'm giving you one compound. You try to do that. You try to do that. Can I give you?
Okay.
Okay, good.
Yeah.
Question C is here. They are saying calculate the empirical formula. They are saying calculate the empirical formula. Calculate the empirical formula of hydrocarbon in bracket carbon and hydrogen in bracket carbon and hydrogen which contain what they contain, which contain 85 something is there, which contain 85, which contain 85.7% of carbon and 14.3% of hydrogen. If they are saying if molar mass of carbon is 12 and hydrogen is 1 and hydrogen is 1, they are saying hydrogen is 1. So this all the information they have given, carbon and hydrogen elements are there. Okay, and their option number A, they have said what is the option? CH, option number CH3, option number 2, CH2, option number D, CH4. Which can be your answer? Can you please tell me? Can you stop? Stop.
Okay. So the elements are hydrogen, and carbon.
Hmm.
Yeah. And then percentage of mass, 85.7
Hmm.
and 14.3,
Hmm.
which adds up to
100.
100. Okay, so that means that it's equal to the mass. So 14.3 grams and 85.7 grams.
Hmm.
And then
Hmm.
we have to divide by the molar mass.
Hmm. To get
Is the
the
molar
number
mass
of mole. Hmm.
C is 12.
Hmm.
So 85.7
Hmm.
divided by 12.
Hmm.
And hydrogen, so it stays the same.
Hmm.
So we get
Hmm.
7.15.
Hmm.
Then
We need to calculate simple ratio also here. Simple
yeah.
ratio means we need to divide both the number by smallest number. So here is 7.15 is there. So we need to divide by 7.15. So it is going to give 1. Okay.
Yes.
And here is 14.3 is there. And if you are divide 7.15. So it is going to give how much? It is going to give
2.
2. Okay. Now they are the
So we
already
get
whole number ratio. They are the whole number ratio. Yes, yeah, no.
CH2. Yes.
So we need not to calculate the whole number because both are the whole number. There is no decimal. Yes, yeah, no.
Yes.
So empirical formula directly you can go empirical formula. What can be empirical formula?
CH2.
CH2. So correct answer will be option number C, I think. Yes, understood.
Yeah.
Can I give you one more problem? Can you solve that one?
Yeah.
Okay. Let me check little better problem I'm giving you. Got it. So here is the questions. Question. A compound, they are saying a compound contains 38.8% of carbon and 16% of hydrogen and 45.2% of nitrogen. Then find the empirical formula. No information have been given for molecular mass. Empirical formula. Find the empirical formula. Find the empirical formula. Nothing they have given here. Option they have said, that is A number they are saying CH5N, B number CH3NH2, C number CH9 CN9NH2 NH2 and D number both A and B, both A and B. Now we need to solve it out. Can you try?
Okay.
Hmm.
Okay, so
Hmm.
our elements are hydrogen and nitrogen.
Mhm.
Oh, and carbon.
Mhm.
And then we have carbon 38.8%.
You solve in your notebook. You solve in your notebook. I'm also solving.
Okay.
And
Okay.
you tell me the options.
Okay.
Hmm.
It always adds up to 100, right?
It will be 100. Percentage is always comes from the 100, but some exception maybe. But here in chemistry, it is out of 100 only.
Okay.
So whatever the percentage mass is there, that is going to be the gram mass.
So we have to get the molar mass ourselves then.
Yes, from the book.
Okay.
You can use here, I can tell you, carbon you can use 12, okay?
Okay.
Hydrogen, you know, 1, and nitrogen is 14. Okay. In
Okay.
your book, they have given too much, the decimal point they have given to you. Don't need to do that much decimal. Okay.
Okay.
The whole number you try to take.
Is it CnH5?
How much is once more, please tell me.
Well, number A.
Number A, CH5N you are saying, na?
Yeah, I wasn't sure what the order should be.
Order, no problem. Order, empirical formula have no order. Molecular
Okay.
formula have order. Empirical formula have no order.
Actually, it's B. It's both A and B, I think.
Yes. You are enough smart to study chemistry. Okay, you are much more enough smart. Okay, so option number D is correct. Okay, so you got to know that is empirical formula, right? Now the one more formula is there that let me check out in the book what the formula they are saying. Got it. So here you see they are saying question, they have rule they are saying. Okay, what the rule is saying, that is the n is equal to empirical formula, n is equal to wait, n is equal to molecular weight upon molecular mass. You can write n is equal to molecular mass upon, they are saying empirical mass. Okay, they are saying molecular mass is equal to empirical mass. This is what the point, n is equal to molecular mass upon empirical mass. The point number 2, what we can do, so we can calculate the molecular mass. Here is molecular mass is equal to what, that is n into empirical mass. N into what, it is going to be empirical mass. Okay, so molecular mass is equal to n into empirical mass. If you see n is the some value will come, suppose that is if you can see that is carbon ch ch2 is empirical formula. Ch2, if someone is saying ch2 is empirical formula and n value is 2 and n is 2, then they are saying then molecular formula. Then they are asking that is molecular formula. What can be the molecular formula? Then it will be C2H4. Why? because they are saying N into empirical molecular formula, N into empirical formula. So C2H4. See? Yes or no?
Yeah, okay, wait, so let's see it. Yeah, okay.
Okay, so we'll be solving one problem based on it. I'm checking the problem. Let's find out the problem, and then we are going to do one problem based on it. Yeah, I got the problem. Okay, but the problem is, although the similar problem is there, here is the problem. You please note this formula. N is equal to molecular mass upon empirical mass. So molecular mass will be given here, and empirical mass you need to calculate. Empirical mass you can calculate simply. Na? Empirical mass means what? The mass of the atoms in empirical formula. Yes or no?
Yeah.
So N value you will get. If N value you are getting, so molecular formula N into empirical mass. No, empirical formula, not sorry, empirical formula. N into empirical formula. So easily you are getting, because this is the CH2 is empirical formula. And N value is how much? 2. So in the empirical formula you multiply by 2. So C2H4 is coming now. Yes, no?
Yes.
So can I delete this?
Yeah.
Okay. So I am giving you one problem. Although you solve half of the problem already, it will be do this one. So question is there. They are saying, if molecular mass is 84 gram per mole, then find the molecular formula. Then find the empirical and molecular formula. They are saying, then find the empirical and molecular formula. Empirical and molecular formula from following data. Empirical and molecular formula from following data. From following data. So from the following data, what they are saying, carbon is, they are saying 85.7%. Carbon is 85.7%, and hydrogen is 14.3%, and hydrogen is 14.3%, and hydrogen is 14.3%. This we have to do. Carbon is 85.7%, hydrogen is 14.3%. Option I am writing here. Option molecular formula CH, and this is the empirical formula, and the together molecular formula they have given C2H2. This is option number. They are saying CH, and this is one bracket, and molecular formula C6H6. C number what they are saying, that is CH, and another bracket they are saying C4H10. Option number D are saying none of these. None of these. So let's try to solve the problem. Yeah, let's try to solve the problem. Can you try? Can you try this?
Okay.
Okay. Firstly, you need to calculate empirical formula. Then we need to calculate the molecular formula. Okay. Molecular mass is there.
80. Okay, so we are carbon and hydrogen. Carbon's
12.
What's it called?
Carbon 12.
12. Okay.
Hydrogen 1. Did you get the empirical formula?
Yeah.
How much?
CH2.
Oh, good. You are doing faster than me. Have you noticed the syllabus of IB chemistry of this one IBDP one term term one?
Notice, no.
Have you seen that one?
No.
You do you have the book?
For the IBDP, maybe my brother has it.
You check now. Check once the book. Okay, then you can study now.
Okay.
If you don't have book, how can you solve the practice problem? That is again problem. Other I'll check and I'll mail you. I am having the PDF. Okay, but 1400 page is there in that. So today I'll try to send you that one also.
Okay.
Hmm.
Yeah, I think
But
my brother has it probably.
okay, you send me the publication name now. Can you
Okay.
share the mail to me? Take the pic of the front page and share to me.
All right.
Because you should know that is in your school which publication is going on there. Okay, because some of the places they are running the Pearson, some of the places some other book they are also running. Okay. So you tell me that is wherever you are studying the college, which chemistry book they are preferring, right?
Okay.
So it will be because what will happen if any particular teacher is teaching the particular publications, now they will ask the problem from that. So you will be able to orally, you will be also able to answer. Na? So when there will be the verbal examination or that is the some oral test will be there, that you can perform better there also, because that type of the evaluation is also there in IB curriculum. Got it?
Okay.
So you please let me know that which publication is going on. You send the main page, 1, 2, 3 page. You send me, right?
All right. Okay.
Through mail or the through WhatsApp. So molecular mass already given here. How much is there? 84, not 85. 84. But empirical mass, how much? How to calculate empirical mass? So empirical mass means what? Empirical formula mass. Empirical formula mass is CH2. So carbon is 12, hydrogen is 2. So how much is going to be? 84 upon what? 14. Yes or no?
Well,
So
what if because it's CH2, does it not become +4 or no? Oh, it's 2. All right. Okay. Got it. No, never mind.
So what can become? It's coming 6.
Hmm.
Yes, na?
Yes.
So molecular formula, if you are talking about molecular formula, so molecular formula, what we wrote, that is N into empirical formula. Yes, yeah, no.
Yeah.
So N into empirical formula, N value is going to be 6. Empirical formula is CH2. You multiply all by 6. So C6 and H6 to the 12. C6H12. Oh, this is the wrong option. I wrote C6H12. So option number B is they have given C6H12. This is the going to be our answers. Got it?
Yeah, got it.
So this type of problem you need to solve, right? Too many problems you are going to get. The last problem I'm giving you, you solve, and then we will wind up. Okay, the last problem based on empirical formula, little bit good compound question is there. An unknown compound, they are saying an unknown compound contain, unknown compound contain 68.4% chromium Cr and 31.6% oxygen. Find the compound, they are saying find the compounds empirical formula. Find the compounds empirical formula. This is there. Here a question they have there, CrO3, Cr2O3, none of these. Okay, so these are the four options. Here they are saying chromium, they have given chromium. So chromium is they have given, that is 68.4%, and oxygen they have given, oxygen how much is there, 31.6%. These are there. So let us try this one. Can you try?
Okay. What is the molar mass of chromium?
Oh, I wrote something wrong or what? Here they have given chromium. Wait. Chromium something given 52.
Okay.
And here is 16.
Mm. So it's Cr2O3.
Yes. This is the option. So thank you very much. You understood this one, I think also. Empirical formula you understood. Empirical formula is Cr2O3. So this is all about, and in the next class we will be studying, that is limiting reagent. This is also very important. Limiting reagent. Okay, this is the next one.
Okay.
So before that, you send me the syllabus. What are the topics are there in your school? What they are supposed to teach? Okay.
Okay.
Or
Yeah.
if you are having your brothers, if you are having the senior brothers, also try to ask from them. Either you can ask their notes now. Ask their notes.
Yeah.
So if you are asking their notes, so also you can go through that notes. What is problem? You can go half an hour, their notes, so you will be able to understand. That is how they are studying, what they are following, how much they are knowing, what I have taught, how much they are knowing, what you need to know. Okay, what you don't.
Okay.
That also you will be able to understand. So if you can manage their notes now, it will be much more effective. Very effective. Very
Okay.
effective. when I was in the in our colleges, so during summer time, no, we got the summer vacation. We were not spending. My father never allowed to spend the time, waste your time to go to relatives. What he said, he just brought the books of the my elder brothers or the some other places. If you don't find the books, no, they are not giving the book. They will ask the notes also. So they were giving the notes. If I will got the notes, we read out the notes in summer time itself. So in during the high school now, before the starting of the new session, I gone through all the syllabus. So when the once the teacher asked, na, it was become the very motivating. When they asked, we were knowing. So we answered the much. You know, we brother and sister now answer too much in the school, too much. So it's very much motivating. Once you answer in the class of 50 student, in the group of 50 student, you started answering, you started explaining to the teachers or to the friend. It's too much motivating. Getting my point?
Yeah.
So you please follow these things also. These are the tricks. You have to learn this one, that how you can grow, how you can top in the class. You need to know that what other friends are doing in your circle, in your classroom. Just ask from them also. You know? Just got
Okay.
it?
Yeah.
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 Bye bye. Bye bye. Take care.
Okay. Bye. Have a nice
Bye bye.
evening.